So, I don't mean to be negative, but we're going to talk about negation. So you can actually decide to add a not as you build your antecedents, and sometimes it makes a lot of sense. So the not operator is specified using \plus. Kind of weird, but there you go. And let's consider the following facts. So we have parent, Sally, Jane. So Sally is a parent of Jane. Oops, no semicolon there. And parent, Sally, John. And if you recall, I had a sibling rule that said X is a sibling of Y if the following is true. There's some parent, P for X, that is the same parent, P for Y. And if we did a query like this, sibling X, comma, Jane, in other words, who are Jane's siblings? When this gets resolved, we're going to get two answers. We're going to get X equals Jane and X equals John. Now, why is that? Well, if you just look at the way this clause is set up, right? Jane is definitely a sibling of herself because the parent P for Jane is Sally, and we can then do the parent P for Jane again, or we can take, so the parent P for Jane is Sally, so we're going to have P be Sally, and then we're just looking for parents that satisfy P equals Sally. Well, Jane is one of them, so that's not great. So it would be nice to get rid of that duplicate, and it turns out that using negation we can do that. So if I add an extra antecedent, and that antecedent is \plus, X equals Y, period. So now I'm saying P is the parent of X, and then P is the parent of some other Y, and X and Y can't be the same. So that will avoid the X equals Jane when we do this particular sibling query. So that's pretty nice. Now, there's kind of interesting things that you can do then if you've got negation. So let's take a look. Well, negation, and I want to consider now just the facts in the database. All right, so I'm trying to figure out the right order I want to do this in. Okay, so consider the following facts. Human, Bart. So Bart is human. And human, Lisa. Lisa is human. Now consider this query. All right, if we say human, Bart, this will say yes. All right, but what if we were to do this? What if we were to say human, Homer? Is Homer human? The answer will be no. Now, is Homer a human? Well, yeah, Homer's a human. It's just that the fact that Homer's a human is not in our database. So this is a problem. This demonstrates something that's a problem in Prolog called the closed world assumption. And the closed world assumption basically means that all of the data that Prolog needs to answer any question you might possibly have, any query you might possibly have, needs to be in the database. So if you're going to ask a question like human Homer, you better have a fact about Homer being a human in the database, or deliberately not have it in the database. So in effect, if you think it's okay to say human Homer or not, you're basically saying, I can ask a question about anything being human, and I'm going to get an accurate answer because the data will be in the database. Either something is human or it's not. And if it's not in the database, it must not be human. So that's called the closed world assumption. You have to be careful about that when you're building systems based on Prolog databases. So you could also say, well, is Homer not human? That's even crazier, right? So also because of the closed world assumption, because it can't find Homer in the database, it'll say, yeah, I can tell you for sure that Homer is not a human. And that's also a fallacy based on the closed world assumption that all the data that you need is in the Prolog database. All right, let's take a look at something else here that may or may not get you in trouble. So consider the following facts. Bart is a human. Lisa is a human. Donut is a food. And Bart is a food. All right, now we would very much like to avoid cannibalism. So our goal here is we want to avoid cannibalism. All right, so what if we issued a query on the fly that said this? All right, to avoid cannibalism, what we're going to do is we're going to say, well, first of all, we're going to say whatever we're going to eat can't be human. So first of all, it has to not be human. And secondly, it needs to be a kind of food. All right, so if this was our query, this could either be an antecedent which defines safe food, or it could just be a query that you type in. If you do this, if this is your only antecedent, this is going to end up with no. We're not going to be able to find anything that matches X. And that has to do with how unification occurs. The first thing we're going to do is we're going to look at this antecedent and we're going to try to resolve human X. So we're going to find human Bart, all right, and human Lisa, all right? And then we're going to negate those. So human Bart is false, so we cannot use X equals Bart to try to resolve food because X cannot be something that is a human. So X equals Bart results in a fail because we're taking not human and Bart's a human. And X equals Lisa will result in a fail because Lisa is also human. And the unification stops there because the first antecedent causes us to process all of the facts about humans, and they're all false because we've said we're not interested in anything that's human. All right, so we can get this to work. All we have to do is change the order that the antecedents are made present. So what we're going to do here is we're going to say food X first, followed by not human. All right, so if we do that, we're going to have X equals donut, and that will make food equal true. And if we try to say human donut, that returns false, and then not a false is true. So this is going to be something that works. X equals donut is going to work. Then we're going to try food of Bart. So we're going to try X equals Bart. All right, and then we're going to look over and say, is there a human Bart? There is a human Bart, that's true. So not human Bart is false. So we're going to have a true for food, but a false for the second antecedent. So X equals Bart will not be satisfied. And so we will end up with some food that we can eat that avoids cannibalism if we follow the second set of antecedents. All right.